Hey there, welcome to TechX Bytes. In this comprehensive tutorial, you'll master Git Bash from the ground up. Git is the world's most popular version control system, and knowing how to use it effectively through the command line is essential for any developer. By the end of this tutorial, you'll be confidently managing repositories, collaborating with teams, and handling complex Git workflows. Let's dive in and transform you from a Git novice to a command line Git expert. Git is a distributed version control system that tracks changes in your code over time. Think of it as a sophisticated save system that not only remembers every version of your files, but also lets multiple people work on the same project simultaneously. Git Bash is a command line interface that brings the power of Git to Windows users, providing a Unix-like environment. Even if you're on Mac or Linux, mastering Git through the command line gives you more control and understanding than any GUI tool ever could. It's the difference between driving an automatic car and a manual one. Both get you there, but one gives you true mastery over the machine. To get started, we need to install Git. Visit the official Git website and download the installer for your operating system. Follow the instructions to set it up. If you're on Windows or macOS, Git Bash will handle everything for you. Once the Git is installed and running, next we'll verify the installation. Now that we have Git installed, we need to set up our environment. We'll verify the installation and check the version. This will help us ensure that Git is properly installed and ready to use. Now that we've confirmed Git is installed, we need to configure it with our identity. Git needs to know who you are so it can attribute your commits to you. This is crucial for collaboration and tracking who made what changes. We'll set up your global Git configuration with your name and email address. These settings will be used for all your Git repositories unless you override them in specific projects. Let's create our first Git repository. A repository, or repo, is essentially a project folder that Git is tracking. We'll create a new directory for our project and then initialize it as a Git repository using the git init command. This command creates a hidden Git folder that contains all the metadata and history for your project. Once you run this command, Git will start paying attention to changes in this directory. Great, we now have a Git repository. But what exactly is happening here? Let's explore the structure that Git has created. The Git directory contains all of Git's metadata. This is where Git stores the history, configuration, and tracking information. Your project files live in what's called the working directory. That's the space where you actually edit and create files. Let's create our first file and see how Git perceives it. Now that we've created some files, let's see what Git thinks about them. The git status command is your best friend in Git. It tells you the current state of your repository. This command shows you which files are tracked, which are untracked, which are staged for commit, and which have been modified. Think of it as Git's way of giving you a snapshot of what's happening in your repository at any given moment. This is crucial to understand. Git has three main states for your files. The working directory is where you make changes to your files. It's your normal workspace. The staging area, also called the index, is like a draft of your next commit. You choose which changes go here. Finally, the repository is where Git permanently stores snapshots of your project. Files move through these states using specific Git commands. Git add moves files to staging, Git commit moves them to the repository, and various other commands help you move information between these states. Let's start tracking our files by adding them to the staging area. The git add command tells Git, I want to include these changes in my next commit. You can add files individually or use git add to add all files in the current directory. The staging area is like a loading dock. You put things there that you want to ship out, commit together. This two-step process, add then commit, gives you control over exactly what goes into each commit. Now let's add our second file. We can add files one by specifying each file name individually. This gives us precise control over what gets staged. Let's add our hello.py file to the staging area using the same git add command we used before. Now let's check our repository status to see both files staged and ready for commit. There are several ways to add multiple files at once. You can use patterns like *.py to add all Python files, specify multiple files separated by spaces, or use git add to add everything in the current directory. The git add command is incredibly convenient. It adds all files in the current directory and subdirectories. However, be careful. Make sure you actually want to commit all those changes. It's easy to accidentally include files you didn't intend to stage. Sometimes you'll add files to staging and then realize you want to try a different approach. The git reset command lets you unstage files so you can try different staging strategies. This is perfect for learning. Let's unstage our files so we can demonstrate the different ways to add files. This shows you how to undo staging when you want to try something different. Perfect, now our files are unstaged again. Let's try adding files using a pattern. This will add all Python files at once. Let's use a pattern to add only the Python files, which demonstrates selective staging. Notice how only hello.py was staged, but readme, md, is still untracked. This is selective staging. You can choose exactly which files to include in your commit. This is very powerful for organizing your commits logically. Now let's reset again and try the git add approach to see the difference. Now you've seen several different approaches to staging files. Each has its use case: individual files for precise control, patterns for file types, git add for convenience, and multiple files for specific combinations. The key is knowing you can always git reset to unstage and try a different approach. The git commit command creates a permanent snapshot of your stage changes. Think of it as taking a photo of your project at this exact moment in time. The M flag lets you add a commit message directly from the command line. This message should describe what changes you made and why. Good commit messages are like leaving notes for your future self. Write commit messages as if you're explaining to a colleague what you did. Be specific and descriptive. Your future self and your teammates will thank you. Now let's create our first commit with a descriptive message that explains what we're adding to the project. Let's break down what Git is telling us. Main is our branch name. Root commit means this is our first commit. A1B2C3D is the short commit hash, unique identifier, and the summary shows 2 files were created with 2 lines added. Let's check our repository status after the commit to see how things have changed. Nothing to commit, working tree clean, is Git's way of saying everything is saved and up to date. Your working directory matches exactly what's in your last commit. This is the state you want to see after a successful commit. Don't worry, Git has your back. If you realize you made a mistake in your commit, wrong message, forgot a file, etc., you can undo it. Let's learn about Git reset so you feel confident experimenting. The above command you see undoes your last commit but keeps your files staged. This is perfect when you want to fix your commit message or add more files to the commit. Head ~1 means go back 1 commit from the current position. Let's say we want to improve our commit message. We can undo the commit and then recommit with a better message. This is a safe way to learn. Perfect. Notice that our files are still staged green, but the commit is gone. It's like we pressed undo on the commit but kept our staging. Now we can commit again with a better message or make more changes first. Now let's commit again, this time with an even better commit message. See how powerful this is? You can experiment, make mistakes, and easily undo them. Git reset with soft flag is like a gentle undo button for commits. This makes Git a safe environment for learning and experimenting. Congratulations, you've made your first commit. Now let's see the history of our project using git log. This command shows you all the commits in your repository, starting with the most recent. Each commit displays the commit hash, a unique identifier, the author, the date, and the commit message. As your project grows, this becomes an invaluable tool for understanding how your code evolved over time. Let's make some changes to our files and see how Git tracks them. We'll modify our existing files and create a new one. This is where Git really shines. It can detect exactly what changed in each file, line by line. Understanding how Git tracks changes is fundamental to using it effectively. Git doesn't just store files, it stores the differences between versions, making it incredibly efficient. The git diff command is incredibly powerful. It shows you exactly what changed in your files. Without any arguments, it shows the differences between your working directory and the staging area. This is perfect for reviewing your changes before committing them. Git diff uses a standard format where lines starting with plus are additions, lines starting with are deletions, and unchanged lines provide context. This granular view helps you understand exactly what you've modified. Now let's stage and commit our changes. This time, we'll use git add to add all changes at once, then commit with a descriptive message. Notice how the workflow is always the same. Make changes, stage them with git add, then commit them with git commit. This consistent pattern becomes muscle memory as you work with Git more. Each commit should represent a logical unit of work, a bug fix, a new feature, or a specific improvement. Let's explore our growing commit history with some advanced Git log options. Git log is incredibly flexible. You can format the output in many ways, filter by date, author, or content, and even visualize the branch structure. These variations of Git log will become invaluable as your project grows and you need to find specific changes or understand the development timeline. Branches are one of Git's most powerful features. Think of them as parallel universes for your code. You can work on new features, experiment with ideas, or fix bugs without affecting your main codebase. The default branch is usually called main or master in older repos. When you create a new branch, you're essentially saying, I want to try something different without messing up what's already working. You can switch between branches, merge them together, and even have multiple people working on different branches simultaneously. Let's create our first branch. We'll use Git branch to create a new branch called Feature Login, where we'll work on adding a login system. Then we'll use Git Checkout to switch to that branch. Once you're on a different branch, any commits you make will only affect that branch. Your main branch remains untouched. This is perfect for experimenting or working on features that might take several commits to complete. Git has evolved over the years and introduced some newer, more intuitive commands. Let's learn about git switch and git restore. These newer commands make Git more beginner-friendly by having clear, single purposes. Git switch is the modern way to switch between branches. It's clearer in purpose than Git checkout, which can do many different things. While Git checkout still works, using git switch makes your intentions crystal clear. Let's use the modern git switch command to go back to our main branch. The C flag with git switch creates a new branch and switches to it in one command. This is equivalent to the old git checkout B, but much clearer in intent. Now let's create and switch to a new feature branch for working on a dashboard feature. Let's verify that we're now on the new feature dashboard branch and see all our available branches. The asterisk, and green highlighting show which branch you're currently on. This is your active branch where any new commits will be added. Now let's do some work on our feature branch. We'll create a simple dashboard file and commit it. This demonstrates the power of branches. We can experiment and build features without affecting our stable main branch. If this feature doesn't work out, we can simply delete the branch. If it does work out, we can merge it back into main. This workflow encourages experimentation and parallel development. Since we're on a feature branch, this is a perfect time to experiment. Let's say we want to try a different approach to our dashboard. We can reset our commit and try implementing it differently. Let's reset our commit and try a different implementation approach. This shows how branches are safe spaces for experimentation. Now let's modify our dashboard implementation and commit it with a different approach. This demonstrates how you can iterate and experiment safely on feature branches. See how powerful this workflow is? We tried one approach, then reset and tried a completely different implementation. Feature branches combined with Git reset give you the freedom to experiment without fear. You can always undo, try different approaches, and perfect your solution before merging. Our dashboard feature is ready. Now let's merge it back into the main branch. First, we switch back to main, then use Git merge to bring in the changes from our feature branch. Git will automatically combine the changes from both branches. If there are no conflicts, changes to the same lines in the same files, Git performs what's called a fast-forward, merge, or creates a merge commit that combines both histories. After successfully merging a feature branch, it's good practice to delete it to keep your branch list clean. The D flag safely deletes a branch that has been merged. Git will warn you if you try to delete a branch with unmerged changes. If you really want to force delete a branch, even with unmerged changes, you can use -D, but be careful. Keeping your branch list clean makes it easier to see what features are currently in development. So far, we've been working with a local repository. But Git's real power comes from its ability to sync with remote repositories, copies of your project stored on servers like GitHub, GitLab, or Bitbucket. Let's simulate this by creating a remote repository locally, then learn how to connect to it. There are two types of Git repositories: regular repositories, with working directories where you edit files, and bare repositories, which only store Git data and are used for sharing. Remote repositories are typically bare. First, we create a directory that will hold our remote repository. By convention, bare repositories use the Git extension to clearly indicate they are Git repositories without working directories. This simulates creating a repository on a server. Let's create a directory to simulate our remote repository. We're using the Git extension following Git conventions for bare repositories. In real life, this would be on GitHub, GitLab, or a server. The bare flag creates a repository without a working directory. This means it only stores Git data, commits, branches, etc., and doesn't have files you can edit. This is perfect for sharing between developers. Now we initialize it as a bare repository. Bare repositories are designed for sharing. They store all the Git data, but don't have a working directory where you edit files. Let's look at what's inside our bare repository. You'll notice it doesn't have the files you'd normally see in a working directory. Notice how the bare repository contains the same folders you'd find in a Git directory, but there are no project files like README, MD, or hello.py. That's because bare repositories only store Git metadata. They're like the Git folder without a working directory. Now we connect our local repository to this remote repository. The name origin is a convention. It's the default name for your main remote repository. Now let's connect our local repository to this remote repository. We'll call it origin, which is the conventional name for your main remote. Let's verify that our remote repository has been added successfully. The V flag shows both the fetch and push URLs. In real development, you rarely create bare repositories manually. Usually, you either clone existing repositories or connect to repositories created on hosting services like GitHub. But understanding how they work helps you troubleshoot and understand Git better. Now let's push our local repository to the remote. The git push command uploads your commits to the remote repository. The first time you push, you typically use git push u origin main, where u sets the upstream tracking, meaning future pushes can just use git push. Origin is the conventional name for your main remote repository, and main is the branch we're pushing. This makes your code available to others and creates a backup of your work. Let's simulate a common scenario. Another developer wants to work on our project. they would use git clone to create a local copy of the remote repository. Cloning downloads the entire repository history, creates a local working directory, and automatically sets up the remote tracking. This is typically the first command you run when starting work on an existing project. Let's clone our repository to simulate a second developer joining the project. Now let's simulate a collaborative workflow. Our collaborator will make some changes, commit them, and push them back to the remote repository. This represents a very common Git workflow where multiple developers work on the same project, each making changes and sharing them through a central remote repository. Understanding this workflow is crucial for team development. The collaborator now pushes their changes to the remote repository. Since the upstream tracking was already set up during the clone, they can simply use git push without additional arguments. This uploads their new login functionality to the shared repository, making it available for other team members to pull down. Now let's switch back to our original repository and get the changes that our collaborator made. The git pull command fetches changes from the remote repository and merges them into our current branch. It's essentially git fetch, download changes, followed by git merge, integrate changes. This keeps our local repository in sync with the remote and incorporates our collaborators' work. It's important to understand the difference between git fetch and git pull. Git fetch downloads changes from the remote but doesn't merge them into your working branch. It just updates your local copy of the remote branches. Git pull does a fetch followed by a merge. Sometimes you want to see what changes are available before merging them, which is where git fetch is useful. Let's demonstrate this difference. Now back in our original repository, let's use git fetch to download the changes without merging them. This allows us to see what's coming before we decide to integrate it. After fetching, we can use commands like git log or git diff to examine the incoming changes. This is particularly useful in team environments where you want to review changes before incorporating them into your work. Sometimes, Git can't automatically merge changes because both you and a collaborator modified the same lines in the same file. This creates a merge conflict that you need to resolve manually. Let's create a conflict scenario to learn how to handle it. Conflicts are a normal part of collaborative development, and knowing how to resolve them is crucial. Now when we try to push our local changes, Git will reject them because our local repository is behind the remote. When we try to pull, Git will detect a conflict because both versions modified the same file. Git will mark the conflicting sections in the file and will need to manually resolve the conflict. This teaches us that communication and coordination are important in team development. Git has marked the conflict in our README (MD) file. Let's look at what it looks like and then resolve it. Git uses special markers to show you the conflicting sections. Head marks the start of your changes, == separates the two versions, and commit hash marks the end of the incoming changes. We need to edit the file to choose which version to keep or create a combination and remove the conflict markers. Sometimes you're in the middle of working on something when you need to quickly switch branches or pull updates, but your changes aren't ready to commit. Git stash is perfect for this. It temporarily saves your changes and gives you a clean working directory. You can then apply the stashed changes later. Think of it as a temporary clipboard for your work in progress. Let's see what stashes we have and then apply our stashed changes back. Git stash list shows all your stashes, Git stash show shows what's in a stash, and Git stash pop applies the most recent stash and removes it from the stash list. You can also use git stash apply to apply a stash without removing it, which is useful if you want to apply the same changes to multiple branches. Git provides several ways to undo changes, and it's important to understand the differences. Git reset moves the branch pointer and can modify the staging area and working directory. Git revert creates a new commit that undoes the changes from a previous commit. Reset rewrites history, dangerous if shared, while Revert preserves history, safer for collaboration. Let's explore both approaches. Git reset has 3 modes: Soft keeps changes staged, mixed, default unstages changes but keeps them in working directory, and hard discards all changes completely. Let's see the differences. Be very careful with hard as it permanently discards your work. These different reset modes give you fine-grained control over exactly how you want to undo changes. Sometimes you need to share changes with someone who doesn't have direct access to your Git repository, or you want to selectively apply specific commits from one repository to another. Git's patch functionality is perfect for this. You can create patch files that contain the exact changes from one or more commits, and then apply them elsewhere. This is useful for code reviews, sharing fixes, or maintaining multiple similar repositories. Interactive Rebase is one of Git's most powerful features for cleaning up your commit history before sharing it. You can reorder commits, combine them, edit commit messages, or even split commits apart. This is particularly useful for creating a clean, logical commit history before merging a feature branch. Remember, only rebase commits that haven't been shared with others, as rebasing rewrites history. Cherry picking allows you to apply specific commits from one branch to another without merging the entire branch. This is useful when you want to bring over just a specific bug fix or feature from another branch. Let's create a scenario where we want to selectively apply a commit from another branch. Cherry pick is great for hotfixes or when you want to test a specific change in isolation. Tags are used to mark specific points in your Git history, typically for releases. Unlike branches, tags don't move, they permanently point to a specific commit. There are two types of tags: lightweight tags, just a pointer to a commit, and annotated tags, which include metadata like tagger name, date, and message. Annotated tags are recommended for releases as they provide more information and can be signed for security. Git aliases let you create shortcuts for frequently used commands. This can save you tons of typing and make your Git workflow much more efficient. You can create simple aliases for common commands or complex aliases that combine multiple operations. These aliases are stored in your Git configuration and work across all your repositories. Let's set up some useful aliases that will speed up your daily Git work. Git hooks are scripts that run automatically at certain points in the Git workflow. They can help enforce coding standards, run tests before commits, or automatically deploy code when pushing to certain branches. Hooks are stored in the Git hooks directory and can be written in any scripting language. Let's create a simple pre-commit hook that checks for TODO comments before allowing a commit. Git is highly configurable, and learning how to customize it can greatly improve your productivity. You can set up different behaviors for different repositories, create custom diff and merge tools, and configure Git to work better with your editor and operating system. Let's explore some useful configuration options that can make your Git experience smoother and more personalized. This diagram shows the complete Git workflow we've learned today. Starting with repository initialization and configuration, through the basic add commit cycle, branching for features, collaboration through remotes, and handling conflicts. Remember these key best practices. Commit often with descriptive messages, use branches for features, always pull before pushing, resolve conflicts carefully, and communicate with your team about significant changes. This workflow will serve you well in any development project. Here's your comprehensive Git command reference. These are the essential commands that will cover 90% of your daily Git usage. Bookmark this section and refer back to it as you continue your Git journey. Remember, the key to mastering Git is practice. Start using these commands in your own projects, and they'll quickly become second nature. Fantastic! You've just completed a comprehensive journey through Git Bash, covering everything from basic repository management to advanced workflows and collaboration techniques. You now understand the fundamental concepts of version control, can confidently work with branches, collaborate through remote repositories, handle merge conflicts, and use advanced features like stashing, rebasing, and cherry picking. Git is an incredibly powerful tool, and you now have the foundation to use it effectively in any development project. Remember that mastering Git is an ongoing process. The more you use it, the more comfortable and efficient you'll become. Keep experimenting with different workflows, explore additional Git features, and don't be afraid to dive deeper into the areas that are most relevant to your work. Your future self and your teammates will thank you for investing the time to learn Git properly. Your Git education doesn't end here. Here are some next steps to continue improving your Git skills. Practice these commands on real projects. Explore Git hosting services like GitHub, GitLab, or Bitbucket. Learn about Git workflows like Git Flow or GitHub Flow. Investigate advanced topics like Git submodules and subtrees, and consider learning about continuous integration and deployment with Git hooks. The Git community is vast and helpful. Don't hesitate to explore the official Git documentation, participate in open source projects, and ask questions when you're stuck. Remember, every expert was once a beginner, and every mistake is a learning opportunity. Keep coding, keep committing, and keep growing as a developer.